Hello there, Oliver. I find this whole concept of time travel quite fascinating, and I love all those TV programs and films and books where you have multiple timelines and people whizzing backwards and forwards in time, creating paradoxes. They seem to do this really well in Doctor Who and Star Trek, although I thought that the Back to the Future stories were particularly weak in that respect. You mentioned in your video sending back a note through time and the potential for that to cause a paradox if, once receiving the note, you then decided not to send the note back to your past self. But actually there's a bigger problem here than just the paradox. If you look at the note itself, it's made from atoms that already exist in your time frame. So sending these back means that the same atoms will exist twice, and the universe will have somehow created mass out of nothing, which is something that violates the laws of conservation of mass and conservation of energy. So I'm going to try and illustrate this with an example, and I'd be really interested in hearing from anybody who could tell me, what flaws there are in the line of reasoning. Now I'm going to make the assumption that time behaves linearly, and that we've got a time machine that can send stuff back 10 minutes. So it sends it back to the same universe rather than many universes. So what you decide to do is that you will take a single grain of sand and you will send it back to your past self 10 minutes ago, plus anything that has come through the time machine. So the first time that you do this, you will send back a single grain of sand. But as soon as you've done that, your previous self has the original grain of sand that you were planning to send back, plus the one that came through the time machine. So that version of you will send back 2 grains of sand. The past version then has the original grain of sand, plus the 2 that have now come back through the time machine. So you can see where this is going. There's clearly something wrong with this model because you've got a positive feedback loop here with potentially no limit on it at all. Now, the same thing is going to be true of energy as well. Unless the machine is kept at absolute zero, there are going to be photons of electromagnetic energy that will make their way through the portal. If we just concentrate on infrared photons for this example, again you've got the potential for this positive feedback loop. If the room is at temperature T, there's going to be a number of infrared photons flying around the room, of which some will go through the portal. And they'll go back 10 minutes. And by going back 10 minutes, they will effectively raise the temperature of the room 10 minutes ago very slightly. So if we follow the loop around again, because the room is slightly hotter, it's now at T plus N, the Stefan-Boltzmann law dictates that there will be more photons flying around. And so statistically, it's likely that more photons will pass through the portal. And this consequently heats the room up further 10 minutes ago, and so on. The most obvious implication of this that occurs to me is that as soon as you turn on a working version of this machine, it's going to vanish in a fireball unless you've got an incredibly powerful cooling system. And that still doesn't actually get you past the fact that you're creating energy out of nothing, which violates the conservation laws. So I think that the practicalities of travelling back in time have got some way to go yet.